Alright, this is Geometry Lesson 1, G Lesson 1 on the website, straight up G. We are talking about using the Pythagorean theorem to solve for missing sides in a right triangle and determine whether a triangle is a right triangle given three side lengths. You may or may not have seen the Pythagorean theorem before. I will tell you how it works. I'm not going to get into a giant demonstration on why it works. That's fun to explore though, so if you'd like to explore it, please do so. Alright, so first of all, we need to know, this is where you will take some notes. If you have your notebook, get it out. If you don't, go get it, pause the video, get it out, and take some notes. The Pythagorean theorem, which evidence suggests was not actually made by Pythagoras. Pythagorean theorem. This is a vocabulary word and a formula to boot. So this is very important to start, put a definition. It says that the sum of the squares of two legs is equal to the hypotenuse squared. That's fancy talk for square one leg, square another leg, and that's equal to the hypotenuse squared. The word leg and hypotenuse, let's define those as well. Leg. A side of a triangle. If it's a right triangle, not the hypotenuse. Wow, that's really loud. Sorry about that. Hypotenuse. The hypotenuse is the longest side of a right triangle. I'll abbreviate for right triangle. Always opposite or across from the right angle. Okay. Note that the Pythagorean theorem, a squared plus b squared equals c squared, needs additional explanation. So let's give an example to explain this. First of all, here's a triangle. This is a leg. This is a leg. And this is a leg. This is not a right triangle. The Pythagorean theorem does not apply. There's no hypotenuse to be seen. There's no right angle. You cannot use the Pythagorean theorem for this triangle. The relationship does not hold true unless the triangle is a right triangle. So let's add that to our Pythagorean theorem. That's why I left some space here. For right triangle only. If your triangle's wrong instead of right, it won't work. The triangle has to be right, so make sure it knows what it's talking about. Okay. Another example. No Pythag. Here. Here's another example. We have a right triangle. Some right angle. You know, this one's 3 and this one's 4. We have to identify which ones are the legs and which one is the hypotenuse. Well, the hypotenuse is always directly across from the right angle. So the hypotenuse is the longest side as well. It's this one. That's the hypotenuse. So this is our hypotenuse. Applying the Pythagorean theorem, the sum of the legs squared is equal to the hypotenuse squared, or a squared plus b squared equals c squared, where c is the hypotenuse. If you'd like to add that to your right triangle here, formula, hypotenuse might be a good idea. Hypotenuse is a fancy word for the longest side, which is the side across from the right angle in a right triangle. So a squared plus b squared equals c squared. Equals c squared, perhaps. There we go. Well, the a is 3, and we square it, and the b is 4, and the c we don't know. We need to solve for c. So what do? Well, we can combine like terms and simplify first. So 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. How do we unsquare? If you remember from the last unit, to get rid of a square, the opposite of a square is a square root. So we're going to square root both sides, which gives us a plus or minus. Don't forget that. we'll have plus or minus 5 is equal to c. It's definitely not negative 5, at least with the context we have. That doesn't make sense. So we're going to get rid of that minus solution because that doesn't make any sense. Oops, wrong button. That's right. So now we have plus 5 is equal to c, or just plain old 5 is equal to c. We've solved for the third side of this triangle. The Pythagorean theorem can also be used in situations where you don't have all the legs. So say you have a leg in the hypotenuse, and you will need to do some algebra to solve those in those situations. Let's do a few examples here. At this point, I strongly suggest that you pause the video and do this on your own if you have not already. Otherwise, you can continue and watch and grade as you do so. I'm trying to solve for x according to the instructions. Write an equation you could use, then actually solve it. So let's do that. Oops, I moved the screen. Didn't mean to. So it turns out we have two right triangles. We've got 3, 6 something triangle. These are the two legs, 3 and 6, and x is the hypotenuse. So 3 squared plus 6 squared equals x squared. We're going to add these together and square root both sides, which gives us 45 equals x squared. Square rooting both sides now, we get plus or minus square root of 45. We only care about the positive one, so this is plain old square root of 45, which is going to be close to 7, but not quite 7, maybe 6.8, I would guess, maybe 6.85, something like that. About 6.8. We can use our calculator to actually calculate the square root of 45. 6.7, I was a little off. So it's about 6.7 for this x. And we'll do the same thing for the Pythagorean theorem here, but notice that we have the hypotenuse and we don't have one of the legs. It is very important that you plug this in correctly. 8 squared plus I don't know squared, x squared, is equal to 17 squared. Right? So if you happen to know your 17 times table, you know that 17 times 17 is 289. 8 squared is 64, and then we have plus x squared is equal. How do we solve for x squared? We're going to use opposites and inverses. The opposite of plus 64 is minus 64, which leaves us with 289 minus 64, which is 285 to 25. That's awful convenient, because the square root of 225 when we square both sides is 15. Super cool. We don't have to worry about a decimal here. Alrighty, taking a look at this problem. This is a really fun problem. How far does a baseball travel from home plate to second base given just this information? Turns out you're going to need to make some triangles here because we have this right triangle right here. This is a right angle, they said. And you have 90, 90, and something. I can tell you right now that it's the square root of 180 because I happen to know a nifty relationship trick that hopefully you'll learn in your next class. But we will calculate using the Pythagorean theorem. So 90 squared plus 90 squared equals x squared. I don't know. Oh, and I told you my trick incorrectly anyway, so we'll get there though. Use a calculator for this guy. 90 squared is 8100, and we add those together because there's two of them to get 16200. That's equal to x squared, and we square root both sides to get rid of the square and get x alone. Is plus or minus the square root of 16200. Is that a whole number? Nope, it's about 127.28. 127.28 is approximately equal to x. So that's how far. It goes about 127.28 feet. Pretty cool. Now we need one more set of notes in order to answer this question, so get your notebook out. We'll talk about what's called the triangle law. It turns out when you have a triangle, if you have two sides, say they're both 6, if the third side is as big as these two sides combined, let's imagine we kind of stretch these sides out so they become flatter and flatter until they're stretched out into kind of a straight line like this. And they're still both 6. If the next side, the third side, is the same as these two added together, 12, you cannot make a triangle out of that because these are just as long as this side, and there's no way you can make a triangle. Which means that any two sides of a triangle must add to less than the third side. When I say less, I actually meant more. Any two sides of a triangle must add to more than the third side. Because if they're less, it's not going to stretch far enough. It won't reach. You can see that this, you couldn't make a triangle out of two sticks. It's not going to happen. You need something different than that. So in this case, the law that you'll write down in your notes is the law of the triangle inequality law. That's what we call it. Excuse me. It says for any triangle ABC, meaning that it has the points ABC on all of its points, so its vertices there. For any two sides, let's change that so that we're talking about the sides instead of the points. It'll make this easier to label. This now is side A, side B, and side C, not point A. For any two sides, A plus B, they must be greater than the third side C. They cannot be equal. They have to be greater. If they're the same, we get two sticks in a row. If they're less than, the sticks don't even reach across. There would be like a little gap in the middle, and they wouldn't have any possibility of being a triangle. Little tiny arms and a big head. Just not sure how well this triangle was thought through. So your triangle inequality law, which is extremely useful actually in a lot of higher math, we use this very often to prove various things, is any two sides of a triangle must add to a greater sum than the third. Okay, so looking at this, does this satisfy that rule? Well, it turns out it does. Is it a right triangle? Well, it would have to satisfy the Pythagorean theorem. Which side must be the hypotenuse? That one. Why? Because it's the biggest side. So we have to see if 8 squared plus 15 squared equals 17 squared. And since I really just love computers and computer programming, and that's so useful to know, we're going to use Excel to prove this. So we'll do side 1, side 2, and the hypotenuse. We could call these legs, I suppose. So if my side 1 is 8, and my side 2 is 15, the hypotenuse must equal the first one squared plus the second one squared. And then we can see that we must also square root both sides to get this thing by itself. So we're going to square root that result. And the function for that is SQRT, squirt. Does 8 squared plus 15 squared equal 17 squared? It does. This is a right triangle. Cha-ching! Oh, my check marks aren't as pretty on this program. Darn it. I like the one at home better. All right. Does this satisfy the triangle inequality law? Is 15 plus 20 larger than 25? Yes, it is. So it's a possible triangle. Cool. Is it a right triangle? Does 15 squared plus 20 squared equal 25 squared? Question mark. Let's use our program. 15 squared plus 20 squared is in fact 25 squared. Very true. Cha-ching! Yep. This is kind of fun to play with when you have three whole numbers in a row like this. It's called a Pythagorean triple. And there's quite a few of them you can use and memorize, and they're used in construction and various other applications. It's fun. Okay, we're done with this lesson.